So hi there, welcome to lesson 1. So we'll be talking about date and time formats in raw form and really going into a lot of details here. And when I mean by raw form is, if you remember the journey to credible data image that we have been sharing across the modules, we mean when the data comes from the client or comes from data collection point, it could come in two forms. So the very first form is in the string form. And we had discussed this before that dates can come as string, and how you know is when you import them, they are read in Stata. Recall that we mentioned that dates that come with red, I mean, variables that come in red are string variables. So you can also check that in module 2 if you need to, brush up. But the default color for strings are red, and dates could come in that form. Now, I mentioned raw form. Now, in that form, with the red color, you can really not do what we call date processing. For example, differences between two dates. You can't say this date minus this date. It will not work. So bear that in mind. In raw form, date or time can come as strings. So note that. Another way it comes, of course, is in the numeric form, which I also shared. So it can just be a number. And this is very rare, but it happens. Especially, I said I worked on a project where I just saw date in the data set and I saw a series of numbers. It was downloaded in Excel and sent to us. So we needed to do what we call some kind of formatting. I remember the project like it was yesterday. So basically that's it. It can come raw form numeric. Now, the only difference is, of course, you can do some calculations because data is like a sort of a numeric form. But the way it looks and the way it's structured, you are not able to tell the time. So if you see a number 15 and another number 20, of course, difference between 20 and 15 is 5 days. But what month, what year was that? So it's not usually visually appealing. And if you had worked with us in module 3 for data preparation, you would have seen this. But let's go ahead and now tell you why it's important that you cannot keep them in the numeric form or in the string form as raw. You need to convert them so that you can now check for consistencies in the data. So let's take a few questions based on a data set that I'm going to show. So this is data of about 5 people here. We have the first question: who is the oldest respondent? That may be easy to pick, by just looking. The same thing, how many respondents are not qualified to drive? So there are two things you need to check that consistency. So let's assume this data is for those who are qualified to drive. So to find that, you have to know what the day of the recording or the day you are watching this video, and then use that, or the year rather, to find out. In my own country, you have to be 18 years old to be qualified to drive. And the third question is, how many will be qualified to drive by 1st of February 2013? So note that the current date of this video recording is 2023. And then we're talking about those who will be qualified to drive by 2033. So please note that. So the very first question, very easy to spot. 29th August seems to be the earliest date here. And if since it's the date of birth, that will be for the oldest respondent. We had 2015, 1995, 2017. So next question is, if this date or this year is 2023, these two people will not be qualified to drive because apparently they are less than even 10 years old from what you can see. So I can see all this and I can process it mentally because they're just 5 lines. Let me move on to the third question. So, who will be qualified to drive by first? By that time, this person will have been 18 years old. So the challenge actually is not the questions, it's the volume. Now, if I had 500 lines, I had to scroll down and hope I don't miss a line to get the oldest, get those who are not qualified, then start ticking and processing one after the other. That does not make sense. And that's why you cannot leave dates in the raw numeric form or the raw string form. So in order to process, we need to establish certain facts about date and time, which you may have seen, but you did not take note of. They call it technically in Stata a date mask, but yeah, I call it date parts or time parts, or parts of time variables. So you must have seen like some kind of digital clock like this before, and it will help us illustrate. So we have there the hours, that's 8:03 p.m. September 1, 2015. We also have the minutes, and then we have the month written out there, which is capital M, and I'm going somewhere. Hours in small h, minutes in the lowercase m, and the uppercase M is for month. We also have the day of the month, which is a capital D, and then the year. This is just the basic syntax that you find. So I just missed out seconds, and I'm sure you have seen clocks that have that. So these are the 6 major parts, and we'll be referring to them more or less throughout this module from time to time. Significant parts of this module will be referring to them. So when data is in its raw form, string or numeric, they are not really, what's the word, optimal in appearance and in use. And I'll explain that before. So I need to explain how Stata sees the date variable, which I'll call the calendar variable, and the time variable, which I'll call the clock variable. So the date variable is like in a calendar form, like you can see here, and the clock variable is listed here. The clock is listed here. Technically speaking, the time that is the clock. So I said one is clock, one is calendar. Stata recognizes it with a date. So I need to put that. So anytime you are giving a time variable in Stata, there is a hidden date variable involved. And that's the only way it can reference in its head the time you are giving it. So that's especially if it's a standalone, there is an invisible date variable. So 17th July 1960, that's fine. You can quote it as a standalone variable. But whenever you code for time or clock, as we call it, clock and calendar, you would find the whole works. That is the date, the time was given. So let's say you started an activity 4 o'clock yesterday, and you ended the activity 3 o'clock or 3 p.m. today. So the date also helps Stata to know which one was more. But even if you write I just know someone did something from 4 o'clock to 7 p.m., it still gives both of them the same reference date. So you know that 7 to 4 was 3 hours, So just for you to know that in the head of the brain of Stata, there is more details to the clock. So in the clock, we can say it's still the calendar, but the calendar can stand alone. So I hope this is clear and very useful. So the functions used with Stata is date and clock, but I rather use the term calendar and clock because sometimes these things, are used interchangeably. So date is basically for that calendar thing, which you see on the calendar daily, but clock is what you see on the clock, including the date. So clock includes calendar. Uh, Another thing to note too is that Stata recognizes dates in a unit called days. So whenever you do your conversion, what you are seeing is days. But clock recognizes milliseconds. The value you'll be seeing, especially in numeric form, is milliseconds. That is a second divided by 1,000. Very important thing to also establish is the reference point. Any day in numeric form, that's data or date or calendar, as I have been calling it, that Stata refers to, is referring it as the number of days from 1st of January 1960. In the same light, any time Stata is collecting, or clock in this case, is from midnight, that is 000 hours of the 1st of January 1960. Now that reference point is very important, so I'll give an example. The 31st of December 1959, which is a day before 1st of January, right in front of your screen, is going to be -1. But 1st of January 1960 is 0. That's the beginning. 2nd of January is +1. So when I see -2 in a data set for date, it is actually referring to the 30th of December -2. 31st is -1. 30th of December is -2. It's 2 days away in the negative sense from January 1st, 1960. So that is very important. So these three concepts of time you need to please keep at the back of your mind, because we'll be referring to them a lot in this module, starting even from this lesson. So please take note of that. So with dates come in variety of formats, and you don't see that in the practical sessions. It can come 1st of October 1960, and it can come in this order. And I'm talking about even when you have done the conversion. When you look at it, it can look like this, and that's what we're going to do in the very last two lessons of this module. But time is usually including, or let me use the word, clock includes calendar. Just don't forget that concept. I hope it will help. And there's always a hidden time variable there. So I hope this helps. These are the fundamentals. When we start doing all the theories and the what's the word, the class work and task, we will explain it better when we start. We pick a data set and try to explain what happens there. So I hope this has been useful, and I intend to see you in the next lesson, where we'll be talking about converting from strings. Now we see them in their raw form. We know the components in this lesson. We've identified all the components within the data frame. Identified those three basic concepts: the concept of reference to a certain date, the concept of how the measurements are made, days for date, and then milliseconds for clock. So all these concepts are very important that you know. So you could rewind back a few minutes and write. If you have questions, let me know what you will want to do. If you also have any feedback, please just let us know in the comments. We'll try and improve the quality of the videos. We hope you have gotten enough resources to be able to manage or produce credible data. Thank you so much for your time, and I will see you in lesson 2, where we'll be talking about converting from strings.